So the most common types typically used in domestic installations are ground source heat pumps, and basically there's two different types of a ground source heat pump. The first one would be one that has a vertical borehole or a vertical loop, and they're particularly used in areas where the property has limited garden space or limited area around the property. So you basically drill straight down into the ground and you put in a borehole or a vertical loop. Where there is suitable land or suitable sized garden available, the horizontal loop is the more cost effective option. And you can see in the top right hand side here, basically that's typical type of horizontal loop that's placed in a shallow pit in the garden for a ground source heat pump in a domestic setting. The other common type of heat pump used for domestic installation is what is known as an air source heat pump, and you can see a picture of the one in the bottom right hand corner here. The air source heat pumps are more versatile in that they can be installed onto most properties regardless of available area outside, and they extract their heat from the air. They're also suitable for flats, and as they attach to the outside wall of the property, are quite easy to retrofit onto the building. So that would be your main types of heat pump. So you'd have a vertical loop, or as I said in the last slide about a borehole, but basically that's where the pipe will come out and goes vertically, and used traditionally where there's limited area around the house. You can also have your horizontal loop, as you can see it's just a horizontal loop in the ground here. Pretty common nowadays are the slinky loops. You have a slinky spring that spreads out gives a large surface area of pipework but in a small area of garden. And then you also have pond loops. So if you have a pond or a river near, you can also operate a heat pump by extracting the heat from the pond or the river. So let's have a little bit more look at detail at how a ground source heat pump works. So basically what it does is it allows you to heat your home with energy from the ground. And ground source heat pumps use pipes which are buried in the ground that extract the heat from the ground. So a little schematic here on the right, you have your ground heat exchanger outside, you have your heat pump, and then you have your heat distribution system inside the house. Now, heat pumps work particularly well with underfloor heating applications because of they work most efficiently at delivering heat into the house at or around somewhere between 40 to 55 degrees C, which is exactly the temperature that an underfloor heating system operates at its best or at its optimum. Radiator heating typically requires standard radiator heating typically requires temperatures of 65 degrees to go into the radiators, but you can get low temperature radiators again that can operate with the lower temperatures that a heat pump can provide. So the heat can then be used once it's extracted from the ground outside to heat radiators, underfloor or warm air heating systems, and also to provide hot water in your home. And the way a ground source heat pump works, it basically circulates a mixture of water and antifreeze around this loop of pipe that's called a ground loop, and that's buried in the garden. So you use the antifreeze in the mix to stop the fluid freezing in the winter periods. And basically the way it works, here's a picture here of a tightly fitted slinky in a trench dug in a garden. So heat from the ground is absorbed into the glycol water mix and then passes through a heat exchanger into the heat pump. The ground in your garden stays at a fairly constant temperature throughout the year under the surface, so the heat pump can be used throughout the year, even in the middle of the winter. So the ground temperature, unlike the air temperature, doesn't tend to drop as much in the winter time, so there's always available heat there that can be extracted using a heat pump. The length of your ground loop really depends on the size of your home and the amount of heat you need. So the more heat you need, the larger the ground loop that you'll need to install at your property. And longer loops basically draw more heat from the ground, but obviously then will need more space in which to be buried. So it's sort of a calculation, just the size of your loop is calculated based on the heating demand for the property. So the ground source heat pump systems, they're what are known as closed loop systems. So the geothermal heating works with the earth and the sun, basically. So the sun warms the ground. So this is where the sort of the discrepancy between whether it's geothermal or whether it's actually a version of solar energy, because of where does the heat in the ground come from. Obviously the low shallow pits in the garden, the heating in the ground comes from the sun, and so the sun heats the ground. So basically, a geothermal heating system works in harmony with both the earth and the sun to provide your home's heating and cooling needs. Your high strength pipe made of plastic, thermoplastic, is put into the ground and filled with the glycol water mix, and then basically that is used in a closed loop within the heat pump and pumped around to extract the heat from your garden. As I say, longer loops can draw more heat from the ground. They do need more space to be buried in. And then if space is limited, that's where you use a vertical borehole can be drilled instead. So you can see in the little sketch here in the bottom right hand corner, instead of the heat loop coming out into the garden in a slinky, it basically goes straight down into the ground and straight back up again. So again, quite a common installation method, particularly where area is limited. And you can see here, but it does require a lot more expense for the installation of a borehole based system, and you need to basically drill a large hole down into the ground, and you need to be careful of aquifers, obviously drains, etc. underneath the property, that you don't pierce into any drainage systems, any water systems. So there's a lot more cost and expense with installing this type of system, but again, they work equally as well. So the ground source heat pump works by harnessing heat from underground by pumping water or your water glycol mixed through it. The heat pump then increases the temperature that it takes from that garden, and it's that heat that it is used to provide home heating or hot water. So as the fluid goes around the garden, it'll come in at a low temperature, but what the heat pump does is it amplifies that temperature to a higher, more usable temperature within the house. What a heat pump does need, it needs electricity to run, but the concept behind heat pump technology is that it actually uses less electrical energy than the amount of heat that it produces. So typically that'll be reflected in what's known as the coefficient of performance. So the idea is you put in 1 kilowatt of electric power, 1 kilowatt of thermal power, and then you'll get out 3 kilowatts of thermal energy. And then that'll give you a COP of 3, but we'll have a little look at that in a later slide. But basically the concept is that you get more energy out than you put in electrical energy. So basically what the heat pump does then in a domestic setting is it provides the same role as a boiler does in a central heating system, but it uses heat from the ground rather than burning fuel to generate heat. So it uses a combination of the heat from your ground plus electrical energy to provide you with your hot water, instead of burning fossil fuels to provide heat for space heating and domestic hot water needs. So, just in final summary then, ground source heat pump systems are made up of a ground loop, which is basically a network of water pipes buried under the ground, and a heat pump at ground level. And basically you'll need sufficient space for installation of the system, generally with a garden that's accessible to digging machinery. And that gives you sort of an overview of the aspects of a ground source heat pump and the requirements that you need to have to install one on a domestic property. Now what we want to have a look at in a little bit more detail is actually how does the heat pump cycle actually work. Okay, so